power, size, and raw engineering. These engines had it all. They weren't just about moving machinery, they were about dominating it, commanding respect, and redefining what a tractor could handle. From massive displacement to relentless torque, here are the 12 biggest engines put into old tractors. Number 12, Cummins NTA-855C. The Cummins NTA-855C was a 6-cylinder, inline diesel engine developed during the 1960s, a time when farms were expanding and tractors needed far more power than earlier models could provide. Cummins, already well established in trucks and industrial machinery, adapted this engine for agricultural use to give farmers the steady strength required for heavy implements and large acreages. Its design reflected proven industrial engineering, but was built to work reliably in the field. The engine's design featured a displacement of 14 liters, equivalent to 855 cubic inches. These sizes let tractors carry large equipment without trouble, changing hard tasks like plowing, harrowing, and pulling big trailers into easier work. Farmers could get more done in less time, making long days in the field a bit easier. Torque was very important for how it worked, giving tractors the power to dig soil deeply and carry heavy loads steadily. Reaching about 980 pound-feet, it gave the strong pulling power that made this engine stand out. The mix of torque and horsepower made sure tractors could use many tools at the same time, letting them work well with different kinds of farm tasks. The engine was built to deliver consistent performance during a variety of tasks. Tractors equipped with it could reach a top speed of about 15 miles per hour, enough to keep a steady pace while moving across large fields. Cooling and fuel systems were matched to the engine's size, helping it operate for extended periods without overheating or stalling. Stronger engines paired with heavier tractors also meant fields could be covered in fewer passes, reducing the time required for big jobs. This gave farmers the ability to complete tasks that had once needed multiple machines. The NTA-855C was designed for steady output and durability, which made it practical for continuous use under heavy workloads. With a horsepower rating of 310, it provided the power needed for demanding work, from pulling wide implements to managing big loads. By combining strength with reliability, it became a useful step forward in meeting the needs of expanding farms. Number 11, International Harvester DVT 800. During the 1970s, the demand for tractors capable of pulling heavier implements pushed manufacturers to design engines far larger than those used before. International Harvester responded with the DVT 800, a V8 diesel that marked one of the company's most significant steps into high-horsepower farming. It was part of a period when agricultural equipment was changing rapidly, with larger farms requiring fewer but more powerful machines to cover wide fields efficiently. The DVT 800 carried a displacement of 13.1 liters, which equaled 798 cubic inches. This gave tractors the capacity to manage heavy implements that earlier models could not handle. Its V8 layout provided smoother operation than many smaller engines of the time, while also giving steady performance for long working days. Farmers using machines equipped with it found they could work larger areas with fewer passes, which translated directly into higher productivity on large farms. Horsepower was rated at 350, a level that placed the DVT 800 among the most powerful tractor engines of its era. This output allowed tractors to carry out some of the toughest operations in agriculture, from deep tillage to hauling heavy trailers, without losing momentum. Torque figures for the DVT 800 reached nearly 1,000 pound-feet. This provided tractors with the pulling strength needed for wide plows and deep working tools, making them effective in preparing fields that would have challenged smaller machines. A top speed of about 18 miles per hour gave tractors enough pace to move across farm properties reliably while still being optimized for heavy work. Supporting systems such as fuel supply and cooling were built to match the scale of the engine. Fuel delivery remained consistent under varied workloads, and the cooling system kept temperatures within safe limits during long hours of operation. This attention to supporting systems helped the DVT 800 maintain steady performance without frequent interruptions, a critical advantage when long harvest days or tillage work demanded uninterrupted power. The International Harvester DVT 800 represented a clear step forward in agricultural power. Its large displacement, high horsepower, and strong torque made it one of the engines that helped define the era of big tractors. Rather than being viewed as an experiment, it became a working tool that showed how engineering advances could give farmers the strength to manage larger operations with fewer machines. Number 10. Cummins NTC 350. Farm machinery in the late 1970s was moving toward larger sizes, and tractors needed engines that could handle heavier implements and longer hours. The Cummins NTC 350 was built to meet this demand. using a 6-cylinder turbocharged diesel design, taken from heavy-duty applications in transport and industry. Its purpose was straightforward: give tractors the power and durability needed for the expanding scale of American farming. Cummins, already respected in the trucking and construction industries, adapted its heavy-duty experience to agriculture with this 6-cylinder turbocharged diesel. For many farmers, it became a dependable choice for handling tough soil conditions, transporting heavy loads, and running machinery without frequent downtime, making it a practical solution for the changing scale of modern farming. The engine carried a displacement of 14 liters, equal to 855 cubic inches. This size gave it the capacity to handle jobs that would have been impossible for mid-sized engines of the past. Large plows, wide harrows, and seed drills could be pulled more effectively, reducing the number of passes needed to finish a field. Horsepower was rated at 350, which placed the engine firmly in the high-powered category of its time. This meant that tractors equipped with the NTC 350 could manage heavier operations while keeping a steady pace across big farms. Torque output reached close to 1,200 pound-feet, which was essential for deep tillage and pulling multiple implements at once. This amount of torque allowed tractors to maintain traction in soft or uneven soil, keeping the work moving without constant gear changes. Farmers found that the engine's balance of torque and horsepower made it versatile, as it could manage heavy plowing, transport loads, and general field work with equal dependability. In practice, this meant higher efficiency and less downtime during busy seasons. Top speed for tractors with the NTC 350 reached about 20 miles per hour. While not designed for speed, this allowed equipment to travel steadily between different parts of a farm and across longer fields without delay. Supporting systems were equally important to its performance. Fuel delivery was matched to the demands of its large displacement, while cooling systems were designed to prevent overheating during long shifts. Together, these systems allowed the engine to keep running under load for many hours, something that was crucial during planting and harvest. The design reflected Cummins' background in industrial engines. Strong internal components, reinforced cylinder construction, and a carefully engineered fuel system meant the NTC 350 could operate under heavy stress for long periods. Maintenance was still required, but with regular care, the engine was known to last for thousands of hours of operation. For many operators, it offered a dependable blend of strength and durability, making it suitable for the growing scale of American agriculture. The Cummins NTC 350 demonstrated how proven industrial engine technology could be applied directly to tractors. By giving farmers more horsepower, greater torque, and reliable long-term operation, it helped meet the demands of larger farms and heavier equipment. It became part of the broader shift toward tractors that could manage more land with fewer machines. Power levels are rising, and you've only seen the tip. Stick around, like, subscribe, and you won't believe what's coming next. Number 9. Caterpillar 3406 DITA. Among the largest tractors of the 1980s, the Caterpillar 3406 DITA was one of the biggest engines fitted into farm machines. This 6-cylinder turbocharged diesel provided the power to handle big farm tools and work across wide fields. Its large size and strong build gave tractors the capacity for demanding agricultural jobs, and it was designed to work consistently through long days, so farmers could complete field work with consistency. Caterpillar was already known for engines in construction and industrial machines, and fitting the 3406 DITA into tractors brought that same reputation for durability into agriculture. The engine had a displacement of 14.6 liters, equal to 893 cubic inches, giving it a truly massive size. This made it possible for tractors to handle multi-row plowing, deep soil work, and pulling heavy equipment that smaller tractors couldn't manage. Just its size alone made it stand out from other tractors of the time, marking it as an important part of the story of big farm machines. The engine came at a time when tractor design focused on pure size and raw power. The Caterpillar 3406 DITA had a horsepower of 375, making it a real powerhouse in the field. This much power lets tractors move smoothly across tough ground while running several tools at the same time. Jobs that used to take multiple passes could now be done more quickly, saving both time and effort on large farms. The engine's strong output also allowed heavier trailers and equipment to be used without slowing the tractor, showing just how tough and well-built it was. Torque showed just how powerful the machine was. At around 1,266 pound-feet, at 1,400 revolutions per minute, it gave tractors huge pulling strength. They could dig deep, carry heavy loads, and keep working steadily across tough fields. Together with horsepower, this torque made the Caterpillar 3406 DITA flexible, able to handle almost any farm task easily and efficiently. With a top speed of around 20 miles per hour, tractors could move smoothly between fields, covering large areas without stopping much. Fuel delivery and cooling systems worked with the machine's strong build, allowing long hours of work. The Caterpillar 3406 DITA turned its raw diesel power into reliable performance, driving some of the biggest and most impressive tractors of its time. In the history of old farm machines, the Caterpillar 3406 DITA stands out for its strength, versatility, and tough design. It was more than just a motor. It powered one of the biggest tractors ever made, showing a time when size, power, and capability were what farmers relied on most. Number 8. John Deere Turbocharged Diesel. The John Deere Turbocharged Diesel was designed for tractors that needed dependable strength for both farm and industrial work. Built with durable components, it delivered smooth power delivery and was intended for long-lasting use under continuous strain. Its large size gave tractors the ability to manage heavy implements, making it suitable for demanding tasks that required consistent power throughout the day. Farmers valued it for reliability, knowing it could keep working through long workdays without frequent interruptions. The engine displaced 9 liters, equal to 549 cubic inches. This displacement provided the foundation for high torque and steady performance. Tractors using it could pull large equipment smoothly, operate multiple tools, and maintain efficiency during extended field operations. The turbo system improved airflow and combustion, which allowed the engine to deliver power while keeping stress lower on internal parts. These design choices reflected a focus on practical use rather than appearance, with each component contributing to steady output and long service life. Horsepower was rated at 385, giving tractors the capacity to perform several demanding operations at once. Torque reached about 1,450 pound-feet, which ensured steady pulling strength in tough soil and under heavy loads. The balance between horsepower and torque made the engine versatile, as it could manage transport, tillage, and other heavy-duty tasks without major loss of performance. Supporting systems were built to match the engine's size. Cooling units controlled heat buildup during extended shifts, and fuel systems were engineered for consistent delivery. Together, these features kept the engine working reliably in conditions that often pushed tractors to their limits. Strong materials and reinforced construction added to its durability, helping it withstand many years of use without major breakdowns when properly maintained. In practice, tractors powered by this engine were used daily for some of the most demanding farm jobs. They could move steadily through heavy soil, manage wide implements, and complete long rows without frequent stops. The engine provided a dependable rhythm of power that allowed operators to complete more work in less time. Its durability and consistent output gave farmers the assurance that their equipment could handle whatever the season required. The John Deere Turbocharged Diesel became part of the shift toward tractors that were larger, stronger, and more capable of continuous heavy work. By combining substantial displacement, reliable turbocharging, and durable construction, it provided a balance of power and endurance that fit the needs of expanding farms. Instead of dramatic displays of strength, its value came from steady performance that supported farmers day after day in the field. Number 7. John Deere PowerTech PSX. By the early 2000s, John Deere was moving toward a new generation of engines that not only delivered higher power, but also met stricter efficiency and emission standards. The PowerTech PSX was developed during this period as part of the company's effort to modernize its tractors for larger farms and more demanding conditions. It was meant to provide dependable power for operators who needed to pull wide implements, run multiple tools at once, and keep machines working for many hours without interruption. The engine's role was clear: combine proven durability with updated technology so tractors could handle expanding workloads in a practical and efficient way. Its engine block, pistons, and turbocharging system were reinforced to handle heavy strain, ensuring steady performance under demanding field conditions. Every part of the design focused on durability, reducing wear on moving components and limiting the chances of breakdowns during peak seasons. The PowerTech PSX carried a displacement of 9 liters, equal to 588 cubic inches, which gave it the capacity to deliver strong torque across a wide range of speeds. For operators, this meant tractors could keep working through long hours without losing reliability, making it a dependable choice for continuous service on large farms. Horsepower output reached 409, giving tractors the energy required to handle heavy-duty tasks, such as pulling large seeders, tillage equipment, or transport loads. Torque measured about 1,200 pound-feet, which was crucial for maintaining steady pulling power in deep soil or when operating wide tools across uneven terrain. This balance of horsepower and torque made the PSX versatile, as it could manage both demanding fieldwork and transport duties without losing consistency. Cooling and fuel systems were scaled to match the engine's output. The cooling system prevented overheating during extended operation, while the fuel system was designed to deliver consistent flow without waste. These systems allowed the PSX to maintain stable performance for long hours, reducing downtime and giving operators more confidence during critical times like planting and harvest. Tractors fitted with this engine could be trusted to start early, work through the day, and remain reliable across changing conditions without major adjustments. The PowerTech PSX was not only about output numbers, but also about making tractors practical for the realities of modern farming. Its size, strength, and engineering gave farmers the ability to complete larger tasks more efficiently, reducing the time and effort required for each operation. It reflected a shift toward bigger, more capable tractors that could meet the demands of larger farms, while still maintaining the reliability that operators depended on every day. Number 6. Cummins KTA1150C. Historically, during the time of giant farm machines, the Cummins KTA1150C stood out for its amazing power. Its large, strong build showed it could keep running for long hours without stopping. Made carefully, it combined good fuel flow, turbocharging, and strong parts to give steady energy even in tough conditions. When put in big tractors of that time, it could pull wide tools, carry heavy loads, and move across large fields without trouble. Its size and strength made it clear that even the hardest jobs could be done more easily and without pause. This engine has a size of 18.8 liters, or 1,150 cubic inches, giving it a big and solid presence that adds to its huge power. The large size lets the KTA1150C produce strong torque even at lower speeds, so it can work hard for long periods. Every part, from cylinders to pistons, is built to last, keeping strength and efficiency balanced for heavy workloads without slowing down. Its internal design shows careful planning, with reinforced blocks, better airflow, and smart fuel systems. Everything about it makes sure the engine runs smoothly, even during long days of hard work. Horsepower reaches 525, giving the engine the strength to handle difficult work with smooth and steady performance. This power lets tractors keep working for long hours without slowing down or stopping, making even the most demanding jobs more manageable. The engine converts diesel fuel into usable energy in a very reliable and precise way, showing Cummins' focus on building engines that last. Torque reaches about 4,200 pound-feet, giving the pulling strength needed to move massive tools, trailers, and equipment without losing speed or efficiency. The cooling and fuel systems are carefully designed to keep the engine running continuously while controlling heat and fuel use, even during extended work periods. The KTA1150C delivers consistent power across all types of tasks, whether towing, plowing, hauling, or operating large implements. Its massive size and well-thought-out design make it capable of handling industrial-scale agricultural work with minimal interruptions. Every part, from the turbocharger to the materials used, is built to be durable and dependable, giving the engine the ability to perform at a high level for long periods. Its mix of power, durability, and smart design makes it a very strong machine that can handle almost any job on the field. Over the years, these machines became a familiar sight across farms, working day after day under all kinds of conditions. They shaped the routines of farmers, influenced the way fields were managed, and left a lasting impression on the landscape of agricultural work. Even without highlighting any single feature, their presence marked a period of growth and change in farming machinery, showing how technology and labor came together to keep the land productive. Number 5. Cummins QSX15. The Cummins QSX15 was developed as a high-capacity diesel engine built to provide steady power in demanding conditions. Designed for long hours of continuous use, it combined modern engineering with durable construction to handle heavy workloads without frequent failure. Each component was made with an emphasis on strength and dependability, allowing the engine to deliver consistent output through extended workdays in the field. In large tractors, it gave operators the ability to manage wide implements and multiple heavy tools at once, covering more acres with fewer passes. Its introduction marked a practical step forward in diesel development, showing how improved design could convert fuel into reliable performance for modern farming. The engine is 14.9 liters, or 912 cubic inches, which gives it strong power. The cylinders, pistons, and turbocharger help the engine burn fuel well and give steady energy. This lets the QSX15 push plows through thick dirt, pull big trailers, and work for a long time without stopping. The parts are made to reduce shaking and wear, so the engine works smoothly. The turbocharger brings more air into the engine, helping it run better and stay strong under heavy work. Horsepower reaches 605, giving enough power for tough farm work. Torque is used carefully, providing strong turning force to move heavy tools without stopping. This setup keeps the power steady, so tractors can move smoothly over rough ground or while plowing for long periods. The cooling system and fuel controls keep the engine at the right temperature, prevent it from getting too hot, and use fuel efficiently. The engine worked consistently, needed less maintenance, and handled long, hard workdays without problems. The QSX15 was designed with durability in mind, using heavy-duty components and a fuel and air system built to support long-term use. Its size reflected the level of power it could deliver, providing the capacity needed for demanding farm work. The balance of torque and horsepower allowed tractors to manage large implements effectively, from plowing deep soil to pulling heavy loads. The engine was built to deliver smooth output, maintaining reliable operation across a range of field conditions and weather. For farmers, this meant steady performance throughout long workdays, the ability to operate several tools at once, and reduced interruptions during peak seasons. Efficient fuel use further increased its practicality, allowing tractors to cover wide areas while keeping output consistent. Number 4. Detroit Diesel 12-volt 92T. In the late 20th century, larger farms and heavier implements required engines that could deliver more consistent power over long hours. Detroit Diesel responded with the 12V92T, a V12 diesel that had already proven itself in buses, trucks, and industrial machines. Adapted for agriculture, it gave tractors a level of performance that matched the shift toward larger-scale operations, combining heavy-duty construction with reliable power delivery. The engine relied on a solid foundation of reinforced components to meet constant strain. Heavy pistons, strengthened cylinders, and a high-strength crankshaft were built to withstand punishing use. In the middle of these features sat a displacement of 18.1 liters, equal to 1,104 cubic inches. This capacity was a clear step beyond most tractor engines of its time, giving the 12V92T the base needed for both horsepower and torque, while still maintaining structural integrity during extended workloads. Performance was equally notable. Horsepower was rated at 650, which allowed tractors to handle larger implements without slowing the pace of work. Torque delivery was managed in a controlled sequence, providing steady pulling force across a wide range of conditions. This meant tractors equipped with the engine could maintain traction even in dense or uneven soil, reducing the need for constant gear changes. Turbocharging improved airflow, which not only increased responsiveness, but also helped maintain combustion efficiency when the engine was running at maximum load. Long days in the field placed heavy demands on cooling and fuel use, and the 12V92T was built to handle both. Its systems kept the engine from overheating and helped control fuel consumption during continuous work. Power was delivered smoothly, which lowered strain on the drivetrain and attached implements. For farmers, this meant the engine could be trusted to run longer hours with fewer problems, especially on larger farms that relied on fewer but more powerful tractors. The significance of the 12V92T was not just in its specifications. It showed that large diesel engines first used in transport and industrial equipment could also work effectively in farming. Farmers gained a power plant that met rising demands while still being durable and practical to maintain in the field. Its combination of displacement, horsepower, and torque gave tractors a level of capacity that set a higher standard for performance. The Detroit Diesel 12V92T gave tractors the capacity to handle heavier implements and longer hours than earlier engines. Its V12 layout, 18-liter displacement, and turbocharged design provided steady power for jobs that smaller units could not manage. This made it a practical step toward larger tractors and showed how industrial diesel technology could be applied directly to farming. Number 3. The MAN D4-276. While many tractor engines of its era focused on moderate power, the MAN D4-276 was designed from the start for heavy-duty tasks, offering strength normally reserved for industrial equipment. MAN's experience in truck and industrial diesel design gave it a foundation to build an engine that could withstand long hours of heavy field work. This approach was aimed directly at farmers who needed reliable power for large implements and demanding terrain, rather than the moderate workloads handled by smaller tractors. Durability was central to its design. Reinforced pistons and strengthened cylinder bores kept the engine dependable under high stress, while a carefully tuned injection system allowed fuel to burn efficiently, even during extended shifts. In the middle of this structure sat a displacement of 16.2 liters, equal to 988.6 cubic inches, a figure that placed it among the largest tractor engines of its generation. The combination of rugged construction and efficient combustion gave operators the ability to manage wide plows, multiple implements, and heavy trailers without sacrificing consistency. Performance in the field was equally notable. Horsepower was rated at 663.8, giving tractors enough strength to operate larger implements and maintain steady work during long field sessions. Torque delivery also remained smooth throughout operation, helping machines maintain traction even in soft or uneven soil. Turbocharging supported this by improving airflow, which kept combustion strong and power output smooth under continuous workloads. In day-to-day use, the D4-276 delivered steady performance that operators could rely on during heavy workloads. Despite its size, vibration was kept relatively low, which not only reduced fatigue, but also minimized stress on connected equipment. The engine's consistent pull meant fewer gear changes were required, and its cooling and fuel management systems kept temperatures stable while limiting unnecessary fuel waste. These practical traits made the engine easier to trust during long harvest days or heavy tillage operations. The MAN D4-276 ultimately showed how industrial engineering could be applied effectively in agriculture. Its displacement, horsepower, and torque figures were impressive, but what set it apart was its ability to deliver those numbers in a dependable, usable way across long workdays. By focusing on strength and operational stability rather than compactness or refinement, MAN produced an engine that allowed tractors to complete jobs that smaller designs could not. Number 2. Komatsu SA 6D170. The Komatsu SA 6D170 was developed during a period when farms and construction projects required engines far beyond the size and strength of ordinary tractor power plants. Komatsu, already established as a leading manufacturer of heavy equipment, applied its industrial experience to create a diesel engine that could manage the most demanding agricultural and earth-moving conditions. Rather than designing for small or medium-scale use, this unit was intended for tractors and machinery that had to pull oversized implements, cover broad fields, and operate for long hours without interruption. The displacement measured 23.2 liters, equal to 1,413 cubic inches. This gave the engine an immediate advantage in both torque and horsepower, while reinforced pistons and durable cylinder bores were included to withstand constant stress. The fuel injection system was tuned for efficiency and consistent combustion, ensuring that even during heavy plowing or hauling, the engine delivered steady power. This capacity allowed tractors to manage multiple implements at once, reducing the number of passes needed across large areas and improving overall productivity. Horsepower reached 740, a level that placed it among the most powerful engines fitted into tractors of its era. Torque was delivered smoothly across the operating range, which kept traction reliable and reduced the chance of stalling when pulling through heavy or uneven soil. Turbocharging increased airflow into the cylinders, improving efficiency and keeping the engine responsive even during extended periods of maximum load. Cooling systems and fuel management were designed to prevent overheating and reduce fuel waste, allowing the SA 6D170 to maintain stable performance through long working days. Engines were designed to be dependable under sustained strain. Its size and design minimized vibration for smoother operation, which not only reduced fatigue during long shifts, but also lowered wear on connected equipment. Tractors equipped with this engine could move large implements with less gear shifting and less interruption, giving farmers more consistent results in fieldwork. While the engine's industrial origins were clear in its appearance and scale, its practicality came from the way it translated raw displacement into steady, usable power. The Komatsu SA 6D170 represented a straightforward approach to solving the challenge of large-scale farming. Build an engine with the strength to match the heaviest tasks and the durability to perform them day after day. With its massive displacement, high horsepower, and strong construction, it became a reliable choice for the biggest jobs in agriculture. More than a display of size, it was a tool designed to keep tractors working efficiently when ordinary engines would not be enough. Number 1. Detroit Diesel. The Detroit Diesel 16V92T was introduced during a time when farms were growing in size, and tractors needed engines that could handle implements far larger than before. Earlier designs often struggled with long hours of heavy work, especially on wide fields that demanded continuous pulling strength. Detroit Diesel, already established in industrial and transport sectors, developed this V16 engine to give tractors the kind of sustained output normally reserved for heavy machinery. The displacement measured 24.1 liters, which equals 1,472 cubic inches. This capacity provided the base for exceptional output, but the engine also included reinforced pistons, thick cylinder walls, and a high-strength crankshaft to cope with constant strain. A carefully tuned fuel injection system supported efficient combustion, ensuring that tractors could deliver consistent power without wasting fuel during extended shifts. Turbocharging further stabilized the airflow, helping the engine maintain output under demanding loads. In the field, the engine produced 960 horsepower, giving tractors the ability to pull wide tillage equipment or haul multi-ton trailers across uneven terrain. Torque was distributed evenly, which meant tractors could keep traction steady even on softer or more challenging soil conditions. The cooling system allowed long days of work without the overheating problems common to smaller engines, while fuel management systems kept diesel consumption predictable. This combination allowed operators to complete larger jobs without frequent interruptions. Operators also noted that despite its size, the engine delivered power smoothly with less vibration than expected. This made long hours in the seat less fatiguing, as gear changes were reduced, and the tractor maintained momentum more easily. Components such as pistons and turbochargers worked together in a straightforward, practical manner, turning fuel into steady motion rather than unpredictable bursts of power. These traits gave tractors more working capacity and reliability during seasons when equipment failure could not be afforded. The Detroit Diesel 16V92T became an example of what happened when large-scale engineering was applied directly to farming needs. With a V16 layout, massive displacement, and parts built to endure long hours of work, it offered performance that set tractors apart from most of their contemporaries. It was not simply a bigger engine, but a durable system that allowed farms to manage heavier implements and larger fields with confidence. By combining industrial strength with agricultural practicality, it marked a clear step forward in the development of high-horsepower tractors. From the biggest displacements to the toughest torque, these engines proved tractors could be beasts. Seen one roar, owned one, or have a favorite? Comment now. Like, subscribe, and keep following for more epic machine history.